In previous videos, we looked for relationships between two categorical variables using cross-tabulation, and we compared means when we had one categorical and one continuous variable. In this video, we're going to examine relationships between two continuous variables using correlation. We're going to look at the relationship between respondents' satisfaction with their physical health and their overall satisfaction with their lives. To do this, you need to go to the Analyze menu, scroll down to Correlate, and select Bivariate. When the dialog box appears, select the two variables and transfer them into the box on the right-hand side. The variables we want are overall life satisfaction and satisfaction with physical health. You'll notice that in the correlation coefficients option, Pearson, the one we want, is the default setting, so we don't need to change anything there. We don't need to worry about any of the other options or defaults, so just press OK. For correlations, SPSS produces a slightly confusing table called a correlation matrix. We're actually only interested in one or two of the figures in the table, so we need to know what to look out for and what to ignore. What SPSS is doing in this table is correlating every possible combination of the two variables, which is why you have 4 different cells. The numbers in the top left-hand cell show overall life satisfaction correlated with overall life satisfaction. If you correlate anything with itself, you always get a correlation of 1, which is what you get here. So in this case, it's telling me that if I knew your score for overall life satisfaction, I could predict your score for overall life satisfaction exactly. This isn't very useful information for us, but it's just how SPSS works. The bottom right-hand cell tells us something similar, but for the satisfaction with physical health. So again, it's telling us that if we knew a respondent's score for this variable, we could predict exactly their score for the same variable. Again, not useful, so we can ignore these two cells. The other two cells, the top right and bottom left, are ones we're actually interested in. And in fact, they contain exactly the same information as each other. One tells us the correlation between the variable physical and the variable satisfaction, and the other tells us the correlation between the variable satisfaction and the variable physical. Since the correlation will be the same whatever the order of the variables, and because both cells contain identical information, it doesn't matter which one we look at. The figure we want is the Pearson correlation, and we can see that it's 0.452. SPSS often only includes the decimal point and not the 0 that goes before it, so you have to look carefully at the output to make sure you're reading it correctly. 0.452 is a reasonably strong correlation, so we can be confident there is some kind of a relationship between how satisfied respondents are with their physical health and how satisfied they are with their lives overall. The correlation is also a positive one, so when satisfaction with physical health rises, overall satisfaction with life is likely to rise, and vice versa. The other piece of information that's important in these cells is that is alongside n. In statistical output, n always refers to the number of cases you've got included in the analysis. And we can see here that the number of cases included in the analysis was 1115. But remember that correlation only shows us how closely two variables are related. It doesn't show us how much one variable changes when the other changes. To find this out, we need to conduct a regression analysis. A regression analysis is similar to correlation, but provides us with this extra information. It is slightly more difficult to conduct and interpret, though. To conduct a regression analysis, you need to go to the Analyze menu, scroll down to Regression, and choose the Linear option. This is a reminder that both correlation and regression are only suited to detecting linear relationships, which is something we've talked about in lectures and seminars. You'll see that the dialog box for linear regression is slightly more complicated than the one you use for correlation. One of the main differences is that, like comparing means, you have to decide which is the dependent and which is the independent variable. The dependent variable is our outcome. So in this case, it is overall life satisfaction, as we are interested in the extent to which satisfaction with physical health contributes to overall life satisfaction. So satisfaction with physical health is our independent or explanatory variable. Now we've sorted this out, we can transfer each variable into the appropriate box. There are plenty of options we could select, but for now we'll just keep things simple and press OK. SPSS produces 4 different tables, but we'll only be concentrating on a few of the figures in some of them. The first table just tells you which variables you have used, and you know this already, so you could ignore this or even delete it if you like. The next table, however, is important, so we'll look at that now. You'll see that one column is labelled R. The figure in that column is 0.452 or 0.452. If you check back, this is exactly the same figure as the one we got when we did the simple bivariate correlation earlier. This is because it's the result of exactly the same calculation and is just Pearson's R. The regression analysis produces this value, but as we shall see, it also produces other useful information. Remember that the R value only tells us how closely the data points resemble a perfectly straight line. You'll see in the next column there is a figure called R square. This is simply R squared, or the correlation coefficient multiplied by itself. Although it's related to and derived from correlation coefficient, this statistic is interpreted slightly differently. It's a measure of how much variation in the dependent variable is explained by variation in the independent variable. The R squared here is 0.204, which means that 20.4% of the variation in respondents' overall life satisfaction can be explained by variation in their satisfaction with their physical health. You need to look at the R value as well as the R square, as the R square doesn't tell you the direction of the correlation, whether it's positive or negative. Because it's calculated by multiplying R by itself, it always ends up as a positive number, even if the correlation was originally negative. But the R square value does complement the information given by R by providing a more intuitive measure of how closely one variable is related to the other. We now need to look at the last table, labelled coefficients. The key figure in this table is the unstandardized coefficient in the B column. There are 2 figures in this column. The first one at the top is the value of the intercept. This can be used to help make predictions with your regression model, but it's rarely done in practice in social science, as the sort of regression models we produce aren't usually good enough to be used to make accurate predictions. Of more immediate interest is the figure in the column below, alongside the description of our independent variable. This value is 0.384. So what does this mean? This figure refers to the slope of the line of best fit through all our data points and is an indicator of the effect our independent variable has on our dependent variable. In practice, this means that on average we would expect a respondent's overall life satisfaction to increase by 0.384 points for every increase of 1 point in their satisfaction with their physical health. So if their satisfaction with their physical health increased by 5 points, we would expect their life satisfaction to increase by 5 times 0.384, which equals 1.92, or just under 2 points. So the R and R squared for our model and the unstandardized B coefficient for our independent variable are the 3 most important figures to look out for when you conduct a regression analysis. Together, they provide information on how well we can predict our outcome variable using information about our explanatory variable, but they also tell us how much, on average, we would expect our outcome variable to change for every unit change of our explanatory variables.